Welcome back everyone to another video on the Unknown Coder YouTube channel. As always, I am Ethan, and today we are bringing back another LeetCode video. Like I said in previous episodes, we are going to try a couple different things out, and we're going to make some changes here and there to the series. So that's what we're going to do. We're going to keep modifying and keep working, and this could be a really short series and maybe longer. We'll see how things go. I wanted to kind of push towards the education side, and this is something I don't necessarily train, so it should be pretty fair game and things like that. So that's kind of why I'm doing this. We're still doing our Let's Build Twitter, so those aren't going anywhere, and we're just trying to get our name out there, do some educational stuff, as well as doing some shorts and things like that. Today, we are doing squares of a sorted array, and this one seems to be a pretty simple problem, but there's actually a twist on it that we need to take a look at. And what this problem is asking for is it wants us to take this nums array that we have right here, which is going to be in non-decreasing order, as we can see here, and then return an array. So this part is important. Whenever it says return array, that means we can return a new one of the square of each number, and then we want it once again sorted in non-decreasing order. So this is going to bring some complications in a little bit. Let's go ahead and hop down below and take a look at the examples that they give us. So example number 1, we're going to be giving a nums array, and this is going to be equal to -4, -1, 0, 3, and 10. And what the output's going to be is we're going to loop through here, and then the output out is going to equal to 0, which comes from our 0. Then we're going to have 1, which is going to come from our -1. Then we will have 9, which comes from 3. Then we will have 16, which comes from -4. And then finally we'll have 100, which comes from 10. So we can't just take the output, we can't just square each one of these and put it back into an array. It does actually have to be resorted. Now let's take a peek at example number 2. Example number 2, it's going to give us an array called nums, and it's going to have the values of -7. It'll have the values of -3. It'll have the value of 2, 3, and 11. So once again, we'll go through these, and the outputs will look something like this. First one is 4, so this is going to come from 2. Next one is 9, which will come from -3. Then we have 9 again, which will come from 3, will come from 49, which will come from -7. And then finally, we'll have 121, which comes from 11. Now, I want to go ahead and go back up and take a look at some constraints and also some very important things that's going to help us out in actually solving this problem. So first, we'll go ahead and take a look at our constraints. There's a couple ones that aren't really that crazy. So for example, the 1 is less than nums.length is less than 10 to the 4. So this just basically means that nums is between 1 and 1000, so it's not going to have any empty arrays for us to check, which is pretty nice. And then again, nums I is greater than -10 to the 4, and it's less than 10 to the 4, and I guess less than or equal to, but this just basically means nums is between -1000 and 1000, so nothing crazy here. However, this part is important. The next part saying non-decreasing, this part is important because this is basically going to say, hey, no matter what we do, the smallest number is going to be at the beginning and the largest number is going to be at the end. And this is what's actually going to go ahead and clue us into being able to solve this in O of n time. And then the second thing that we need to take a look at is the fact that whenever you square a number, it's always going to turn out to be positive. If you went back and looked at those examples, you're going to see that each and every number is actually positive instead of negative. Since the array is sorted in ascending order, the large negative numbers that will come at the beginning of the array, such as -4 here or -7 here, whenever they're squared, they're actually going to turn positive and get bigger than some of the numbers that are inside the middle of the array. So what we want to go ahead and do is we want to check the absolute values of the number that's the smallest as well as the number that's the largest, and then go ahead and square that and put it into the array depending on where it needs to go. Once again, this is going to work because the square of a negative number is always positive, and if the absolute value of the smaller number is larger or the negative number is larger than the largest number, then we need to put that at the end of the array. Let's go ahead and hop down to our pseudocode to go ahead and take a look at what this is going to look like. So if you remember in the rules, it just says to place these inside of an array. So we're going to want to go ahead and first create an array of size nums.length. So we want to go ahead and have some array to go ahead and fill it in. And what we're going to want to do is we're going to want to fill this from where index, so we want to say index is going to be equal to nums.length minus 1. So we want to start at the end of the array with what would be the quote unquote largest numbers. Then from here, you want to say for each element, inside of nums. Then we want to check the current largest and smallest numbers absolute value, A, B, S. So we can do that by taking a look at the right side and the left side of the array. And whenever we check them, so if the current smallest value, absolute value, ABS is greater than largest value, largest current value, ABS. This means that whenever we square it, it's going to become positive and it's actually larger than the largest current number. So then we're going to want to set our temp array or result array. Result of index is equal to current smallest squared. Otherwise, we want to do the opposite. We'll set the result of index equal to, and then current largest squared. And then we'll go ahead and do that until we have no more values left. And then we'll go ahead and just return result. Again, if it doesn't want you to create a new array to do this, it'll tell you to do it in place. So that means it is legal for us to go ahead and create a new array. And this is what's actually going to make it a little bit faster for us. So let's go ahead and take a look at our example. We'll just do the first example with this pseudocode. For our example, nums will equal to -4, -1, 0, 3, and 10. So that's our number. So result will equal to empty to start out. And then we'll also have the smallest index equal to 0. So that's on the left side. We'll also have largest index equal to 4, and that'll be the right side. So smallest index of nums is -4. Largest index of nums is 10. So whenever we have iteration 0, nums of s, so small, is going to equal to -4, and nums of L for large is equal to 10. So in this case, the ABS of -4 is less than the ABS of 10. So then we want to go ahead and say that the result of index is going to be equal to 10 squared. We also need a decrement index here. So index minus minus. So now inside I equal to 1, nums of small is equal to -4, and nums of large is now equal to 3. ABS of -4 is larger than the ABS of 3. So now that means that our result of index is equal to -4 squared, and index is going to go down because we're going backwards. Iteration 2, nums of small will now equal to -1, and nums of large will equal to 3. So here, the ABS of -1 is smaller than the ABS of 3, which means that the result of index is going to be equal to 3 squared. Iteration 3, nums of s is going to still equal -1, and then our nums of L, or nums of large, is going to be equal to 0. So here, ABS of -1 is greater than ABS of 0. So now that means that result of index is going to be equal to -1 squared, and that should be iteration 3. And then finally, iteration 4, nums of the small side is equal to 0. Nums of the large side is equal to 0. Here, it's just going to be ABS 0 is equal to ABS 0. So obviously, the result of index is going to be equal to 0 squared. So now we're done with the loop, and we'll go ahead and return the result, which is equal to 0, 1, 9, 16, and 100. That works out as expected. Let's go ahead and hop into LeetCode and take a look at how we can implement this. Inside of LeetCode, we're going to want a couple of variables. Firstly, we need an integer array called result, and this is going to be equal to a new integer array that is the size of nums.length. Then we need an int index to keep track of our current index, and this is going to be equal to nums.length minus 1. And then we need a small index and a large index, so int sidx is going to be equal to 0, and then int large idx is going to be equal to nums.length minus 1. Then we need to go ahead and loop through our nums array, so while index is greater than or equal to 0, because we're starting at the end, we're going to say if math.abs of our nums small index idx is greater than math.abs of our nums of large idx. So if the smaller number is larger than the bigger number's absolute value, then our result of index minus minus is going to be equal to nums of small index times nums of small index. Then we need to go ahead and say small index plus plus. So we need to move the pointer to the right one. Otherwise, what we need to go ahead and do is we need to say result of index minus minus is equal to nums of large index times nums of large index Then we need to move the large index to the left one, so left index minus minus until they meet in the middle, or you run out of indexes to look at. And finally, we need to go ahead and return our result array. And let's go ahead and submit this to see if it works. Terrific. We have a 1 millisecond runtime, which beats 100%. I typoed 3 minutes ago, so that's why you see that, but it works as expected. Everything's good. This is how we can get a OOVN solution to get this down to 1 millisecond runtime on LeetCode. Thank you all for watching. If you appreciate the video, please leave a like, comment, and subscribe. Peace out, everybody, and have a great day as always.